Hi guys, this is actually lesson 1.3. Sorry, I didn't have that on the last one. But if you can see down the side here, we're doing exponents and negative exponents. I'm sorry, quotients and negative exponents. And this week we're working on rules of exponents. And I'll be honest, guys, they can seem easy, they can seem tough. You can think you get it, you go to do the homework, and then all of a sudden you're confused. So the only way to learn how to do these is to kind of put yourself out there and you have to try. Don't worry, okay? I will help you through it, but I need you guys to kind of put yourself out there and really try these. And just like yesterday, the more you write down, the easier it gets. So it says right here, any number divided by itself has a quotient of 1. Remember that. Don't overthink that. 5 divided by 5 equals 1. -7 divided by -7 equals 1. Okay, that's all that means. Number divided by itself. So we have two properties here. The first one is quotient of powers. You can see that right here. We'll talk about that. And the negative exponent property right here. I'm not going to stress about names, but I want you guys to be able to apply these things. Okay? So the quotient of powers. Quotient means divide. And you can see here, that's division. Where actually it's a to the nth power divided by a to the nth. Division right here. So notice that when we same base, just like yesterday, dividing, instead of adding our exponents, we're going to subtract them. Okay, and we'll just do the proof here in a little bit. Negative exponent. So if you look right here, we have a to the negative nth. And notice that's going to equal 1 over a to the nth. And we'll talk about why that is in a second too. So here's the proofs of these. So the proof of the first one here. We have a to the third power divided by a to the second power. Notice they have the same base. Well, if you think of what exponents mean, a to the third power means a times a times a. 1, 2, 3 a's. Just like, if I can erase here, a to the second means a times a. Now, if you think about this for a second, any number divided by itself has a quotient of 1. Well, we sometimes get confused because we think we decided to start adding letters into math, and we're not. Yeah, I know this is the letter A, but really, guys, it's a symbol for an unknown number. This is a number. We just don't know what it is, so to represent that, we put an A. So if you look here, we have A divided by A. We have the number, some number, divided by another number. So any number divided by itself has a quotient, or a solution to a division problem of 1. A divided by A cancels out to 1. A divided by A cancels out to 1. So notice what we're left with. We're just left with 1A here. Now, an easier way to do that, instead of writing out all these A's every time, is to use our quotient of powers property. And if it's the same base, we're dividing, we subtract the exponent. So this here, I could jump to this. A to the 3 minus 2, which would give us a to the first power. Okay. Another example, let's say we had, I'll just write it here, a to the 7th over a to the 5th. Well, they're same base, dividing, we can just subtract the exponents, and that would be a to the 2nd. Now, likewise, using the quotient of powers here, what happens if we kind of switch these exponents around and we have a to the 2nd divided by a to the 3rd? Okay, now it's the same thing. A to the 2nd means a times a to the 3rd means a times a times a, 3 of them. So a divided by a, that number divided by itself, divides out to be 1. That divides out to be 1. And notice we're left with just this 1a on the bottom here. Now we got to be a little bit careful. That doesn't mean we can get rid of and just move it to the top. Okay? Here's the reason. This divides out to be 1. This divides out to be 1. So these are a whole bunch of 1s. Down here we have 1 times 1 times a. So we have 1 times 1, which is 1. 1 times 1 times a, which is a. Okay? But if we use that quotient property, that would be a to the 2 minus 3. That would equal a to the negative 1. So when you have a negative 1, kind of how you think of it is I think of it as a reciprocal or flipping it over the line. What you're going to do is you're going to flip it, switch them around, and drop the negative. There's actually a 1 there. We don't write the 1, but it's there. Okay? So the negative exponent one's a little weird. Think of it as take the reciprocal, flip them around, a to the negative nth over 1 becomes 1 over a to the positive nth. Okay? So you're just going to drop. Every time you flip it over, you're going to change its sign. So, in words, to divide like bases. Oops. Same base dividing, we subtract. We subtract the exponents. Okay. Now, if you have a negative exponent, okay, if you have a negative exponent, you're going to, I'm going to write it like this, and we'll talk about it. We're going to, if you have a negative exponent, take the reciprocal, and I'm going to say for now, drop the exponent. No, drop the negative sign. Okay, so for example, if I had a to the negative second power, I'm going to take the reciprocal here. I'm going to go 1 over a to the positive second. Now, you got to be a little careful here. Now, we'll just go with it. If you were to go backwards is the only part I'm really worried about here. We won't worry about that for now. Okay, so let's say you had x to the negative 7th power. Take the reciprocal, 1 over x this time, and make it a positive 7. Okay. Again, these rules, they're really to make simplifying easier. And the only way to get better, as we talked about in the past, the only way to get better at them is to practice.